let's look at a simple way to understand linear graph. So when you say a linear graph, one thing you have to pay attention to is that what is exactly behind the linear graph, or what can you see, and then you can call that person what a linear graph. So this is one thing that when you see, we can call this guy to be what a linear graph, right? So y is equal to mx plus c. Don't worry about these letters. So the one thing you have to understand is that you must know the image behind the letters. That is the most important thing. Let's see. Now, where is the y coming from? Where is the x coming from? Where is the m coming from? Where is the c coming from? Those are the things that you have to pay a close attention to. So once you get something that looks like this, you can see that this is what a linear map. The difference is that make sure that this x is just an x. It's not raised to any power. Is that okay? Don't worry. Even once you get a concept of how the functions work, you are free to go, and I'll explain that in just a few minutes. So by the way, this is how the linear graphs looks like, right? So those is just some of the examples of what a linear graph. That's a y is equal to 2x plus 1. So you can see that this is just similar to the way the linear graphs looks like, right? So m is a friend of c, m is a friend of x, so where you can see that here 2 is the friend of what x, so meaning m is equal to 2. What about c? C is positive 1, right? So this is just very simple to identify what a linear graph. What about this one? This is also a linear graph, but someone should give you the values of the c, right? So what do you think is the c? So comment down below. Is that okay? Don't worry about that. So the most important thing you have to focus on in a linear graph is that understand how the function works. So I will use this simple diagram to demonstrate that. So the diagram says that input, the machine, and as well as the output. What it means is that in graphing, you have to make sure that you are dealing with three things, right? So three things here is that you have to make sure you have your input, and then you are going to put that input into this machine to get an output. So assuming this input here are a set of ladies, right? Set of ladies. Then when you pick any lady, let that lady enter into this machine, then automatically we will determine the lady's partner. Is that okay? So we have a ladies here which are the input. So in this case, let me call them x, right? So we are going to place this x inside this machine. So the machine is the function, right? That is going to transform this lady to determine what her partner. So the input into the machine, then you get the output. So that is how easy the function works. So you have to make sure that you have the input at your disposal first, and then you plug that into the machine to get the output. Is that okay? That is very simple. So let's see how it works by using what an example to demonstrate that. So this is just a pure past questions. Let's check how. Functions. Is that okay? So two different machines here. So meaning that we are going to have a two different linear graphs. But remember how the linear graphs looks like. So this is what one equation that you have been given. They say y plus 2x is equal to what 1, and then the second one will be what y minus what 3x is equal to what 11. So let's deal with the first part. So how is the linear graph looks like? How does that graph looks like? It looks like, look at what is happening. It looks like y is equal to mx plus c, right? So that's the side. So you have to make sure that you rewrite this thing to be y is equal to something, right? So that is the most important thing. That is what they say when you see, you should call that person a linear graph. Is that okay? So y is equal to something. So here you have to rewrite this thing to be y is equal to something. So here you can see that y is equal to, I just rewrite this one, make the y the subject. So y is equal to 1 minus 2x, right? So this guy looks like what a linear graph, right, by definition. Now in this case, you can see that you are not giving the input, the values of what the x. You are not giving any input to deal with. So in this case, what do you do? What do you do in this case? You have to make sure that you choose your own input. Is that okay? In some cases, you'll be giving the input. That is the most important thing. You have to find the input and then the machine. Now you got a machine. So this is the machine here that's going to transform the input. Now you don't have the input. What are you going to transform? So you need to, in this case, you have to choose your own input. Any values of what? X, that is all positive and negative, right? Any values of that, then you plug that into the machine to get the outcome. Those are the two things you have to need before you move on, the input as well as the machine. In some cases too, you'll be giving the input, maybe let's say minus 3 is less than or equal to what, x less than or equal to 3. Have you seen something like this is what, an input, so meaning that x is greater than or equal to minus 3 and x is less than or equal to 3. So here you are starting from 3, then depending on the values of so minus 3, minus 2, minus 1, 0 up to 3. Is that okay? That is one case. Or maybe sometimes you'll be giving what, a set that is a minus 1, 0, 1, maybe 2, and so on and so forth. Is that okay? So these are some of the input that you are dealing with. But in case you are not giving the input, you have to make sure that you choose what, your own what, values, right? You have to choose your own what, input, and make sure that you include what, negative and positive inside. Is that okay? So let's look at how to tackle that. Here I'm having what, so choose some values of what, x. So here you are going to choose some values of what, the input. So what are the input? The input, so I decided to go for s when x is equal to minus 6. Obviously the first input or the first letter that you are going to plug inside the machine is minus 6, right? So where is the machine? Here is the machine. The machine says that y, to get your partner, this is your partner, right? So to get your partner, you must have 1 minus 2 and then multiply by what, the input, right? So here I got y is equal to what, 1 minus what, 2. What's the input? The input is what, minus 6. So when you do this calculation, you arrive at what, 13. Is that okay? So that is the 13. Now what do? In graphing, you don't work alone. You have to work in pairs, right? You have to work in pairs. So you and your partner. Is that okay? You and your partner. So this can be what, x comma what, y, right? X comma y. So you and your partner, that is how you work in what, in graphing system. So you can never work alone. So the x here is what, the input, and then the y is what, your partner, right? Or maybe y is the output. So I have minus 6 comma what, 13. So this is what sometimes we call what, an ordered pair, right? Or maybe a coordinate point. Is that okay? So make sure that you are working in pairs. So what about if x is equal to minus 4? I just choose some random numbers of the x, right? Is that okay? Because you are not giving any input. Okay. And then when s is equal to minus 4, then the same thing. So the input is minus 4. What is the output? You have to use the machine to transform this to get the output. So this is your partner, meaning that to get your partner, you have 1 minus what, 2 multiplied by what, the input, which is minus 4 here. So this one will give you what, 9, right? So this one will give you 9. So you and your partner, so you are here and your partner, so that will be minus 4 comma what, 9. Is that okay? So in graphing, you work in pairs. You can never work in what, as a single person. You can never work alone if you're a Liverpool fan. Okay. So here is minus 4 comma 6. So the same thing. So when I get to 0, the same thing. I plug 0 into the machine. That gives me what, 0 comma what, 1, right? So when s is equal to 0, I have the partner to go positive 1. So the pair is what, 0 comma what, 1, right? So when x is equal to 4, I have that to be what, y to be equal to minus 7. You can see that. So I just plug this thing into the function being given to me, right, into the machine. So what we have been doing so far, so this is the machine, right? That is the machine. It says that y is equal to what, 1 minus 2x. So in place of the s, I'm putting the input over there, right? So here I'm having when s is equal to 4, then I had y to be what, minus 7. So the ordered pair is what, 4 comma minus 7. And then when s is equal to 6, then I have y to be minus 11. So negative 11. Yeah, I'm having 6 comma what, negative 11. Is that okay? The way I choose the points are two, both positive and negative, right? So 0 is just the middle man here. You can see that I started with what, minus 6, and then I descend to minus 4. Then I go to 0. Then from there I go to 4, and then 6. You can decide to choose your own values, right? Choose your own value on how to plot the point. So that is what you have. How many points over here? So you have 1, 2, 3, 4, and then 5. Is that okay? So you have 5 points on the what, one side. So let's look at the second part. The second part was that the equation is what, y minus what, 3x is equal to 11. So the same thing, we know that a linear graph doesn't look like this. The linear graph looks like y is equal to something. So I need to rewrite this one to be y is equal to what? 11 plus what? 3x. So I'm just taking this guy to the other side of the equation. Is that okay? So that is how I got what? Y is equal to 11 plus what? 3x. So where is the x coming from? S is the input, right? X is the input. Just like the previous one, I choose some values of the x. That is the positive and the negative. Is that okay? And then you plug that inside the machine to get what? The output. So the input, machine, and output, right? So when you do your calculation, so I choose x. You can choose a different values, provided that you are dealing with negative and positive. Don't go for any huge numbers. Is that okay? Yours can be even be smaller than mine, so nobody cares about that. Is that okay? So the most important thing is that you are dealing with the right thing. Okay, so I choose s is equal to minus 6 and so on and so forth. So when I do the calculation, just like the previous part, I had minus 6 comma what? Minus 7. And then when s is equal to 4, I had the output to be 8. And then when s is equal to 0, I had the output to be what? 11. And then when s is equal to 1, I had the output to be 14. Is that okay? So these are the points that you have to plot on the graph. So how many points? We are going to plot like 10 different points on the graph here. So I have a very nice graph over here. So if you don't know how to do this graphing, then one thing you have to pay attention to is that the line here, this line here is what? The x-axis. So this line is the input. So I indicate that with a red pen for you to see exactly what is happening. So these are our input. Our inputs are on this line, and then the outputs are on what? This line, right? So this is how it is. Now, most of the graph is not always the case that you have to divide your graph into two equal parts. The most important thing is that you have to make sure that all the points are on the graph, right? Here the question says that we should use let me check, we should use 2 centimeters to 1 unit on the x-axis. Is that okay? So this is the x-axis. X-axis is the what? The input, right? The x-axis is the input axis. So the input axis, they say you should use 1 centimeter to what? Or maybe 2 centimeters to 1 unit. It means that at every 2 centimeters is what? 2 units, right? So some of the graphs, they have a very deep line. This line, from one deep line to the other is 2 centimeters, right? So from 2 centimeters, is that okay? So they say that every 2 centimeters is 1 unit on this line. Is that okay? On the x-axis, so on the input line. So every 2 centimeters. So assuming from here to here is 2 centimeters, and then from here to here is 2 centimeters, and from here to here is also another 2 centimeters. So starting from the 0, you can see that every 2 centimeters I have 1. That is what the scale says. So that 2 centimeters to 1 unit on the x-axis. The same applies to the what? The output axis, that is the y-axis. They say 2 centimeters to what? 2 units, right? Okay. Now let's see how to plot a point. So we are going to plot the points on what? On this graph. So what are the points? The points are what? You've already calculated out. So remember, as I said earlier on, that is what? Input and output. Input and output. So the machine is the machine, the function that is transforming the input to output. Okay, so now how do you plot a point? Just put me at where you see me. So that's just a simple English analogy that says that the x is 6 and then the y is what? 13. So you are 6 and then minus 6, and then your partner is what? 13. So how do you plot this? We are going to plot this thing out on the graph. So let's just look at that. So you are going to locate minus 6 first, right? Minus 6 on the x-axis. Minus is on the input. So input, this is the input line. Can you see that this is the input line? Remember, I said something earlier on that in graphing you don't work alone, so you have to work with your partner, right? So you are here, minus 6, right? So that is the first thing. Minus 6 is here. You cannot plot this point over here because we know that in graphing you can never work alone, right? So you can never work alone, since that is the reason you have a minus 6. So where is your partner? Your partner is on 13. So you just need to go up. You don't go this way, you don't go like that, you don't go down, you don't go in the slant way. So you have to go up or down, right? After locating the minus 6. Okay, so minus 6, then let's go up. Why are we going up? Because we are going to locate where exactly 13 is, right? So 13 is somewhere in the middle of this guy. Can you see that? So when I move forward, so here I have to go up, 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 straight forward, and then locate what exactly where 13 is. So look at where 13 is somewhere. So 13 is here. Is that okay? So this is where they are supposed to be, right? Remember I said that here we work in pairs. You can never work alone, right? So that is how simple you have to plot what your point. Okay, so I'll pause the video, then I'll come back and come in after plotting all the points, then we move on. So you may consider what doing that. When you come back and come and check the solution. Okay, welcome back. So after plotting the points, you join them with what a straight rule, right? So those are the points that I have this point, this guy here, and then this guy here, as well as what this guy, right? And then the other one gives me that this one, and then this. Is that okay? So these are the two different linear equations that we are having, and then the final part says that you should find the coordinates of what intersection. So where the two lines intersect, so you can see that they intersect here, right? They say you should find the coordinates. So what it means is that you have to find x and y, right? X comma y. Remember I said that in graphing we don't work alone, so right? So you have to find, how do you do that? You just need to, this is where you can see that this is where the two lines are intersecting, right? The two lines are intersecting at this point. So what you have to do is to make a dot towards the y-axis, and then another dot towards to the x-axis, right? Another dot to the x-axis. Then you just have to read the point. All that you need to is to just read the point. So what is here? The guy here is -2. So what is here? Here you can see that this is just in the middle of what 4 and the 6. So the number here is what 5, right? So the coordinates of the 2 points are what? This point is what -2, 5, right? Remember you and your partner, so we are reading this thing from the graph. You can see that here is -2, so the x comes first and then 5 follows. Is that okay? The x comes first and then the y follows. So in this case our x is what -2, and then the 5 is what our y over here. So this is how simple you solve what a linear graph. If you have a problem, just comment down below, right? We are ready to attend to you wherever you are. If you gain some values in this video, just give us a thumbs up, subscribe to our YouTube channel for more details like this. Thanks for watching.